Welcome to our lecture on object-oriented programming, Lecture 13, well, really, Chapter 13 from our book, and I had already gotten it started, and within a minute it crashed. Thank you, Code Blocks on a Mac. So if you're in a studio audience, you saw that I already got things started discussing one of the most important concepts of C++ and any object-oriented programming language like Java, etc. The concept of creating objects, class objects, object-oriented programming. This is one of the largest chapters in the book, and even then it just begins to discuss some issues into this wonderfully large, huge, important world of object-oriented programming. So, getting started, what we want to do is we want to create the class. Now, if you remember how we dealt with structs and enums, we created this entity that we created. It had many internal elements to it, but the problem with that was they weren't very versatile and they were open up for others to go in behind the scenes and mess things up. One of the beauties of object-oriented programming is data hiding. You'll hear all the buzzwords. Data hiding is elements that can only be accessed through public methods. The example I give to students when I teach in the live format is I talk about a blender. You have a blender in your kitchen. You have all the buttons on the front face of the blender. Whip, chop, blend, frappe, whatever the heck frappe is, and you push those buttons and the blender responds to them. The buttons are what you use to get to the behind-the-scenes elements of that blender. If you break open that front case, you certainly can monkey around with the buttons and get tweezers in there and get them to work. But there are a lot of problems. Number one, you're not allowed to do that because that is hidden from you, the user. Even if you know what to do, you shouldn't be going in there doing it because you could get electrocuted, you could damage the appliance, you could void the warranty. So you only use public methods to get to the private information. All right, so we're going to create a point. This point, think of algebra, xy coordinates. You've got Cartesian coordinates, a ordered x, ordered y to plot a point. It's one of the simplest things to do. The book talks about a rectangle, again with two elements, a length and a width. But I'm not going to redo what's in the book because you can read that. Then why do you need the video? I'm going to do this with a point because this point will come in to the future when we discuss inheritance and polymorphism. Okay, 2 more lectures to come. But first things first. Use the keyword class. Class, and I will say point in capital letters with correct spelling. Most objects that I see begin with a capital letter. It's very rare that you'll see an object with a lowercase letter, so here it is with a capital P. And look what happened when I put the curly braces in. It automatically put a semicolon at the end because in C++, the designation of the area of all the class information must end with a semicolon. As you know, most times with curly braces you don't need a semicolon, but this is one of the few times that it is necessary. So we talked about the private information inside the blender that you're not allowed to get to. We'll do private as well here. So you use the keyword private with a colon at the end. And here's where we declare variables. Int x, int y. Okay. That creates private x and y. You can't change them unless you push a public button. And what are those public buttons? So again, that's the public category. Again, notice that here in code blocks or any major IDE, they'll turn color, meaning you can't use them for anything else than what they're written for. So usually you have different categories. Let's create, we call these the constructors. Let's create what we call a default constructor. So I'm going to say point. So if someone invokes the point object with nothing inside the parentheses, it's going to generate 0, 0, the origin. Okay, at least we coders are going to program that. Oh, let me do a save here in case we crash. Okay, then we're going to create one in which we can let the user set their own x and y. Notice how these look an awful lot like functions. Okay, and again, this x and y does not necessarily have to be this. Again, like with functions and function prototypes, But this is what we'll use again for readability. And that's it for constructors. Now suppose we want to get information. We call that those the accessors. And some books colloquially call them getters, but their proper term is accessors. And this could be where we want to get what's the value of the x. So since it's a return, we'll say int get x, and we'll get that information. Also get y. Now a nicety is if you say const at the end, meaning this function will not change internal information. You're the coder. Why you would use a getter to get information and change something while you're at it, that's almost like thievery. You know, you're supposed to go in and get one thing and then you grab a slice of pizza while you're at it. So the const says it doesn't get changed. Book says to do it. I'm ambivalent to it. I don't necessarily do it myself, but there it is. Those are the accessors. If we change things, those are the mutators. Again, setters. We want to be allowed to set our x and y. We set it, we go in, change it, nobody gets hurt. They're voids. Set x. And what are we setting x to? Int some new x. And I'm going to do that because you're going to see how I reference things. And I could have, again, used an x there because it doesn't matter inside the method itself. But I'm going to show you something later involving that where you need to help the compiler from getting confused as to which x you're talking about, or which y for that matter. Okay, so we can take this new x, this new y, go in and change it. Another example I give to students is, imagine those old English, Lord of the Manor. And there's this Lord of the Manor, and he has a butler. And people knock at the door because they want to see the Lord of the Manor. Well, the butler is the one they first meet. And you have to put your calling card on a butler's silver platter. He will take it to the Lord of the Manor, and he will look at it and determine if he wants to see you or not. And then the butler goes back, and it's like, oh, the master shall see you now. And then you go in. So again, if anything needs to be changed, this butler will do that as well. Okay, and I'll be putting in other categories here, but for now, we're going to leave it like this. Now, at the end of this is just the prototype information. We need to create what these do, and again, we're doing it well before we use them inside main. Like if I wanted to create a point object, point P1, and if I try to compile it, it will yell at me because it doesn't know how to create this constructor. Right? Might as well get the compiler going, and it compiled. Oh, but it warned me that it has an undefined symbol. So if I try to run it, it should crash. Has not been built. Yes, there we build. Okay, nothing should come up, or rather warnings. So let's not try to do that first. Let's create this point. Here's what you do. You give it the class name and then a double set of colons. Double colon. They're called the scope resolution operator. So what that means is this point is going to be referring to what? Well, look at this nice little drop down. Okay, thank you, code blocks. You're doing something right. We will then look for the point object that takes in no parameters. So again, just knowing it by hand, I'm going to do that. And since it's a method, we put parentheses at the end. So what's the point object going to do? And of course, with nothing coming in, this is called the default constructor. Set x to 0 and y to 0. Most good objects, when written, have a default constructor. They set themselves to some baseline. Either all their values are set to 0 or to some baseline point. Strings might be set to unknown if the information isn't available yet. Maybe there are certain baselines that you don't want to go below, like you can't be negative. You can't have a negative weight, a negative age, a negative length, etc. So the default constructor takes care of that. So this is 0, 0. In other words, the origin. Now what happens if we have a constructor in which we are actually giving it parameters? So again, I'll just call it int A, int B. And what we'll do, x will be assigned A, and y will be assigned B. Now notice, here's one good reason as to why I changed the variables. Because if I say x is assigned x, it's going to get confused. Which x am I talking about? The private variables or the input variables? I'm going to show you another little cool thing with one of the other methods in which we will purposely have it as the same name, and how you can use any object-oriented language to make sure that you are differentiating between the input variable and the private method, the private member. All right, well, we got these getters and setters. Let's do this. And as I type it out, let's see, what's the first one? I kind of want to do them in order, right? It was the accessor, get x. Okay, get x. Takes nothing in, and all we just do is return x. I know, all this fuss and muss just to return a single element. But that's the rules of object-oriented programming. You can't directly access the private members. You must use a public method to get to them. Okay? Copy, paste. This will be the get y. You know, in some IDEs, I've noticed you can just do a right click and it will build it all for you. I notice that in Java a lot with Eclipse and NetBeans. This will be the setx now. And I'll put in, I'll start it here. I'll put in that x. How do we know which x we set? Oh, and by the way, if these are getters, we forgot to put in their return type. Okay. If you get something, what's its type? It's integer. Here, these are voids. Set x. Okay, so I want to set the private x to that x, and you can see already the confusion here. How do I distinguish this x from the x way up here? Here's what you do. In C++, you say this, and you make a cute little arrow thing with a dash and a greater than symbol. So this means this. Okay? And for my Java friends, in Java, we say this dot x equals x. Okay? So, if you know to change that to a dot, you're now speaking Java. And that's the end of that video. Will it reopen quickly? Who knows? And who knows how much I've lost. So if you don't come up in a matter of 30 seconds, come on, I'll close the video and start another one. Here's what I'm going to do. I'm going to close the video and I'm going to build those others. That way it doesn't waste our time and we can speed things up. Okay? Bye for now.